Good morning, everyone. Hi, nice to see a lot of people here today. Last session, so hopefully we'll get it all done, and that's it for Ignite, right? Okay, so this session is about designing for availability in Azure. I'll cover mainly IaaS, but I'll cover a bit of the PaaS stuff also, just to show the differences between them. All right, so this is the agenda that we're going to go through today. I'll be talking about highly available PaaS, and then highly available IaaS, and what about the hybrid stuff? And along the way, a lot of it is all demos. Just to give you an idea, I only have about 22 slides, of which less than 15 are actual stuff. Okay, so let's just start off. Whenever you talk about availability, the first thing you got to worry about is what we call the RPO and the RTO that you need. So this is something that you have to define for yourself. So when we say RPO, it's recovery point objective. That means the data that you want, how up to date must it be at the point where you recover. RTO means recovery time objective is how fast it gets up and running. Okay? Now, what we always talk about as technical people is the technical RPO and technical RTO. That means we say, well, I'll get your data up to 5 minutes ago, and I'll get your machine up to where it was 2 days ago, right? What we forget is the business part of it. Because the business, when they see these numbers here, they go, well, it's 5 minutes, right? But that means I got to go back and look through 1,000 transactions to see exactly which of them comply. So that's the business part of it that they have to work out. So both numbers have to be fitted together to say that this is what we need as an overall objective. In other words, we give the technical part, somebody else, the BA or some other analyst or the bosses were to say, well, we are willing to have other parts. So this is the first 3 columns that you see, right? You say, hey, I need an RTO within how many minutes if I have a hardware failure. If your data center is gone, well, that's RTO of 8 hours and RPO of how much and all that. Then you get to the next part where you say, before we carry on, please talk to your bosses and say, look, add an extra column at the end. And that column goes, you know, that's how much money you need to pay. Okay? You want me to give you a something that works with 0 RPO? Fine, that's $1 million. Are you willing to pay for that? Nope. Let's talk about the $100,000 solution. Nope. Let's talk about the $10,000 solution. Okay? You have to do that conversation first when you talk about availability. Because if you don't, you end up in a situation where they just say, well, I expect you to get everything up and running within 5 minutes. I don't care how you do it. But by the way, I'm going to pay you that amount of money. Right? Okay, so we all know that's what our bosses all want, right? The bosses all go, hey man, I don't care what it is, it never fails. The RPO is always 0, and by the way, you don't cost me a single cent. Okay, and we know that's not true. So remember, get back to those numbers. Okay? So next, we start off by saying this is what you usually have as a PaaS HA. All right? Now, it's quite complicated, so I'll just break it down really, really fast. The main parts you look for are actually here, Traffic Manager. So this is DNS level availability. So notice there are 2 different regions here. There's a region 1, there's a region 2. And what we are just saying is that any of this region can be active if you want it to. Normally, we keep one of the regions active. The problem with making 2 regions active has to do with data. Note, most of your applications tend to be static. They don't change every 5 minutes. So you can keep the same set of apps on both sides. But your data is the one thing that you have to make sure you can go across. And the geo-replication is a problem because we don't have 0 latency. The law of physics does not allow that. Okay? So let's say, for example, it's 20 milliseconds latency. If you want everything to be up to date at all times, it means that every transaction you do has to incur 20 milliseconds latency. You write something to your database, you have to wait for the other side to respond back and say, I've written it to my side, which means it's 20 milliseconds. So if you want much better response than that, you can't use a synchronous replication. In other words, whenever you write something in region 1, it will take some time before it goes to region 2. That time means that your data will never be 0. Your RPO will never be 0 because you can't keep the same set of data on both sides. All right? Okay. So in Azure, what we have provided is the first piece here, Traffic Manager. Then we provide the ways for you to actually load balance applications within a region. And then we provide little things like your databases here, how we can make them HA, all right? There's different ways between a SQL Azure one versus the IaaS database that you create. And then lastly, how about all your databases, not databases, your content that you put into all the storage accounts and everything, how we actually create that and make that highly available. So it is a combination of all of that that makes the thing highly available, not one item. Okay? Let's start off with Traffic Manager. So Traffic Manager basically is pretty simple. You set it up and then you say, I want to use this, and I use it in 3 different modes. Performance mode, weighted round robin mode, or failover mode. All right? And then lastly, you just say, it will always check by HTTP, because the way it works, it goes like, hey, is your HTTP page up? In which case, I will send traffic to you. If not, I won't. So to cut the story short, let's do a demo. Okay? So what you're going to see here is my virtual machine sitting up in Azure. All right? And we'll get back to that page later. But here is my Traffic Manager up in Azure. So you see here, Traffic Manager, and then you see there's 3 endpoints that I've set up for it. So what's happening here is that depending on the configuration that you set on this guy, the configuration for me is every 30 seconds, I will go to each of these 3 and I will check port 80 and that particular path and see if it's returning a HTTP 200. If it is, I'll leave it up. If it doesn't, I will not send traffic to it. But please note, this is a DNS entry, it's a DNS 30 seconds. So how does it actually work? Basically, I've created a website. I'll just show you what it looks like here. All right, my website is, well, strangely enough, my name.info. So notice here that when I query it, it returns back something. It returns back actually a CNAME record. The CNAME record is that. That CNAME record points then to this guy here, all right, which is some website that I've created in Australia East. If I try it again, you'll find that it'll be a slightly different one. And you go, all right, what the heck is that? Slightly different website. That's exactly how the HA works. Because every DNS query that's made for your website, they send back a different answer depending on where you are. So here I'm running this off Azure in Australia, right? So now let's see exactly what it looks like when I go into this guy here. So he comes in. Come on, back to this guy. All right, see this web page here? It's my Ubuntu web server. I'll show you later. There's actually 5 servers underneath the whole thing. Okay, see that? I do a refresh and it becomes web server number 2, and then I do another refresh and it becomes, well, web server 2, web server 2. Come on, please give me something else. Okay, it changes depending on which one queries and how fast you are. Now imagine if instead of going this way, I've then decided to go to my web server, say, somewhere else in the world, all right? So I've set up some other web servers. Here's the fun of Azure. So I've created a few servers, say, in Azure US. And I have one of my servers is actually sitting in Azure US, right? So imagine now I'm going to a server in Azure US. So that's this guy here. And then I connect to it. All right, so that's RDP sessions, connecting through RDP. Yes, 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 open, click connect. And there you go. And connect. So when I go into this particular site, remember this guy is based in the US, and I query the same thing, lloydlin.info, it will send me to a different site, which you wouldn't have seen coming from Australia, because again, it depends on where you are in the world when you did the query. All right? So if I do exactly the same thing here, and then it pops back and it says, by the way, based on that query, you are now coming to a web server, say, somewhere in the US. Right, this is Web 2. Okay, so notice it looks different from the other one because that one says Web VM, then there's another one that says Ubuntu, and so on. So let me just show you what actually I've done. Okay, so when you come from the US, it automatically goes to Web 2. The reason is because if you look at the Traffic Manager profile that I had here when I created the whole thing, you will see that my traffic manager profile has 3 endpoints. All right, within it, that 3 endpoints, one of them is in Australia, one of them is a VM. It's actually not a VM, it's a set of VMs in Australia. And then the last one is this guy here in South Central US. That's why when you went to the US, it gave you Web 2, because Web 2 is closest to you when you come from the US. When you come from Australia, which is where this machine is, it will automatically give you one of those guys from Australia, either Web 1 or Web VM or so on. Now, imagine if one of them were to die. So pretty fast here, I have decided to kill my VM, or my website rather. So here goes website, bye-bye. Right, so I decided to go to the website in the US and say, well, bad thing happened to it today, and it decided that the website is going to stop. All right? So yeah, Azure US blew up. Poof. Okay, there you go. It's now stopped. So remember what I put down there as a probe, 30 seconds? Within 30 seconds, the thing will be updated. And then when you go and query loglin.info again, it will send you to a different site, no longer in the US, because that's what it means by the 30 seconds that they probe at. Okay? And then imagine if all of a sudden, this guy here, I said, well, you know what? I'm also going to kill off the VM here in Australia. So, well, not VM, this is the website in Australia. So bye-bye website in Australia, come on, please connect. And I'll stop it. Okay, come on. Oh, it is stopped already, is it? No, it's just slow. Okay, there you go, it's stopped now. All right, there you go. So now I've stopped both of them. The only guy left in that thing is the one that says all the VMs. It's actually a load balancer, and then behind it, there are actually 3 virtual machines tied to that. So I'll show you later what it all looks like. But in the meantime, that's all stopped. So now that all these things have stopped, when I go back to my traffic manager now, it should then show up. Eventually, within a minute or 2, it will then say, yeah, I agree, those endpoints are now dead. Okay, see that? So the fact that it recognizes the endpoints are dead, it will then send everything to that guy, because that's the only one that's still alive, right? And how it determines that is it does the probe. So remember, the probe is HTTP or HTTPS, that's all. Okay, now, if I click on this guy here now, and I say I want to go to, it will always be one of the 3 VMs that I have. Either is it the Ubuntu one, or the web server one, VM2, then there's another one which is web VM1. Let's see if we can get it to show up. There you go. All right, so one of the 3 will come up. All right, because that's the internal load balancer in Azure that does that. All right, but now, let's go to the US. And remember the guy in the US who says everything is dead? So all of a sudden, if I go to the US now, instead of going to Web 2, which is where he's closest to previously, he will now go to one of those guys that you have. So that gives you the HA that you need, but only at the DNS level. All right, so that's what Azure Traffic Manager will do for you. Okay, so now that I've shown you what Traffic Manager can do, now how hard is it to actually add somebody else in there? So notice I have a 3rd web server that I haven't added in there. I could effectively say, you know what, that web server, I want it in there now, because all of a sudden I find that I have a need. Something has gone wrong, I deploy a new one really, really fast, and I just add it in. All you do is just click Add, pick it as your endpoint, pick a name for it, okay, and then just say, see that? It can be an external IP address, an app service, or a cloud service. External IP address means your home computer. Well, as long as there's a public IP address to it, okay? And you can make that become the thing. So now, let's pick number 3 here. And this is a different website that I've just put in. And I say, yep, that's him, go. So at this point, he will add that guy in there and put it as part of the whole Traffic Manager profile. Once it's set up, oh, really? Okay. He's basically saying, nah, you got too many of them now. Okay, but yeah, if that worked, then it would have gone through, and then you got, that's a new one there. And then you have another one that will help you. So you can do all these changes on the fly without losing anything. Whatever that was functioning still functions, all right? So there you go, that's Traffic Manager, all right? Now the next thing we have, okay, is SQL Azure. So in SQL Azure, there are a few things that we want to highlight here. When you buy SQL Azure, you can buy at 3 different tiers. I think there may be a few more higher tiers coming, okay, or lower tiers coming, depending on how they go. But this is, by default, the various types of capabilities that you have, all right? Each of them, if you look at the RPO, in most cases, the RPO is 5 seconds. In other words, what we are saying is, if you do an active geo-replication, your data on the other side will appear within 5 seconds, in most cases, okay? And it takes about 30 seconds for you to actually get everything up and running again, all right? So what does SQL Azure HA look like? Let's give you an example here. So imagine now I'm looking at my database server, right? Somewhere in the back end. So here's this guy, here's my site, and then I go to my SQL Azure. So you're going to see here, in SQL Azure, I actually have 2 of them, and these 2 are actually replicating to each other. One of them is the primary, one of them is the secondary, and they are in different sites. Even though it's a bit hard to see, I don't know why they put that thing there, but okay. It's a bit hard to see where they are from this screen, but one of them is in Australia East, which is Sydney. See that? One of them is Australia East here. The other guy is actually in Australia Southeast. Okay? And how easy is it to set it up? Well, basically, all I had to do was go to one of them, and then I just go click geo-replication, and I say, I need you to be geo-replicated, and pick a site for him to be geo-replicated with. There you go, done. Okay, just click that site, click OK, and then it will automatically geo-replicate for you. Now, then you go, wait a minute, my database or rather my website in Australia East just died. I couldn't fix it, but I have a corresponding website in Australia Southeast, right? So how do I make Southeast database become the master? You just click on this, and then you say, I want you to fail over. So at that point, it will initiate the failover. So this is a planned failover, meaning to say no data gets lost. It goes to both of them and go, all right, come on, take all the stuff that you've done, shove it over to Australia Southeast, and then Australia Southeast kicks off. Now, there is a problem here. The connection string you use is different. So you need to update your app with the new connection string. Because when you go to Australia Southeast, it's a different server, although it is the same database. All right, the database name is the same, but the server is different. Now, let me show you how you actually see it when you use SQL Server Management Studio. Okay, so this SQL Server Management Studio, assuming that this is one guy here in SQL Server going in and saying hello to them, right? So this is the guy here in Melbourne, and here I am. I'm going to log on from Melbourne. Log on to Melbourne. So you can see there, he's connected to Melbourne, and there's one database that he has, right? See that? There's a database, couple of tables. I basically use AdventureWorks, so you can see a couple of tables in there. Now, at the same time, I can actually connect to the other guy, right? Because he was still alive. I mean, if he was dead, of course, you couldn't connect anymore. All right? So you can see him here, and he has exactly the same table, the same database, and you should have all the tables and everything inside. So in theory, you should not make any changes on this guy. You are only supposed to look at it, okay? Because this is a read-only part of it, all right? Now, if I were to go back and switch the thing around again or whatever, it doesn't matter, you would see one of them becoming master, and then one of them becoming primary, and the other one becomes secondary again. Any changes I make here, so if I create a new table here and say, call it XYZ, whatever, it doesn't really matter. I'll just call it test1, data type nchar, allow now, yep, and then I'm totally breaking every single DBA rule that you guys have, so yes, that's it, and all right, and then I save this, okay? And I'll call this table 1, yep. All right, so now you see a new table created, and I'll stuff some data into it just for the fun of it. Come on, table, you should be up. And if I were to refresh this guy now, you should see a new table. You go in there, and then you update it, and you stuff a couple of rows in there. You'll find that within 5 seconds, they will appear on the other side, simply because of that capability of geosynchronization. All right? Okay, so if I were to call this that, and the number 1, and then I'll call it David, and the number 2, right? Okay, and there you go. Save that. So now, this table, 2 columns, two data rows in there. Now, if I were to go back and say, hey, oh shoot, this guy hasn't finished his replication, has he? All right. So in SQL Azure, within a region, it is highly available. You don't have to do any extra work to make it highly available within a region. All you need to do is say what other region you want to replicate to. And depending on the level of SQL Azure you buy, you can get, I guess in some ways, slightly faster response. Because the theory is that when we need to replicate, if you're a premium, we'll probably give you higher priority than a guy who bought a basic. Okay, no word stated on that, but that's probably how it will work. Right, there you go. Can you see these lines here? It means that we're actually having trouble trying to replicate the thing right now because it's still in pending status. Trying to cut across, okay? But you get the idea now, how you actually shove your data back and forth. So note, what about your web servers? Then you go, do I need to create a new set of web servers on the other side? The answer actually is this. If you can already deploy something and you can deploy it really fast, you don't actually have to do anything because it maintains on the other side, right? If, let's say, for example, I can deploy the whole server and my whole website and get it up in 3 minutes, then this thing is going to take longer than that anyway to shove across sometimes, and therefore my 3 minutes is more than enough to get the thing up and running on the other side, okay? So let's go back into the next one here. So that's SQL Azure, and SQL Azure has all this capability. Note, for SQL Azure, you can always restore as needed. So again, that's one of those features that you get in here. So you pick one of these guys here, you say, well, my data is crap and there's some stuff wrong. I would like to pull it back up from where it was previously. Then you could actually click on it and say, I want to restore from whatever time in the past. And it will automatically do the restore for you, okay? So that's SQL Azure. Next, let's talk about the, come on, next one. Okay, so we talk about the web apps themselves. So the web apps, we have multiple load balancers. We have a layer 4 and a layer 7 load balancer. The trick in your work is that please tell your programmers to make them stateless. The reason is if they are stateless and you have a session state server at the back end or the database at the back end that controls the state, then it doesn't matter which guy goes to which server. Now, that's what we call theory, right? In practice, you know what happens, okay? Every programmer out there just stuff everything all over the place, and it's not sessionless. It has to go back to the same session. So what we have when we say it's a layer 4 means that it allows you to pick which port you want to direct stuff on. Layer 7 means it will actually work on your HTTP itself and nothing else, okay? So let's kind of demo this part here, all right? So that's where the demo comes in. All right, here we go, layer 4 and layer 7. So remember that 3 VMs that I showed you just now? Those 3 VMs are actually behind a load balancer. So if you look at these guys now, and I'll pick up so this guy is a layer 4 load balancer, and this particular layer 4 load balancer that I've created basically has got 3 VMs in the backend. So what you do in there is you create a backend pool, and then you drop it and you say, hey, these are my virtual machines, which I put in there. All right, that's my load balancer. And then these 3 of them are being load balanced together. Right? There are other stuff that you do. For example, you put a probe. So the probe says that port 80, I will always check on it, verify that it's up before I direct traffic to it. So in this case, notice you can do HTTP and TCP, whatever port you want. And then these numbers basically means that I have given them 10 seconds. If the thing doesn't respond in 10 seconds, I will basically direct traffic to another one. All right? Then you have the load balancing rule. So the load balancing rule I put here is basically port 80. So I just say, for port 80, coming out from the front end IP, this is the public IP address, send it all back to port 80 in the back end and give it to that pool, those 3 virtual machines that you saw. Use that probe to make sure that it's fine, and whether or not you got a session persistence. So if you do, then you say, look, I want to persist by IP. That means whoever IP comes from, that IP will always go back to the same one. If not, you go to the other guy. All right? Now, the part that I did not show you was the fact that this load balancer that I created, the 3 things behind are actually 3 different types of VMs. 2 of them are Windows, but 1 of them is Ubuntu Linux. So what I've just highlighted to you is we don't care, all right? All we care is as long as you respond to the probe, we will send traffic your way. So if your probe is using nginx as a web server versus IIS, we don't care either. We just send all the traffic to it as and when it comes up, right? The other thing you can do is you can do an inbound net rule. So why would you want to do an inbound net rule? Because if I need to go into that particular virtual machine and RDP to it, I create a port that I RDP to that guy, then this other port RDPs to the other guy. So that way, from the same public IP address, I can reach either one of them, but not via 3389. It's 55533 becomes 3389 on the other side. 55534 becomes 3389 on the other machine. Okay? So you can see here how we actually built the layer 4 load balancer. Now, the layer 4 load balancer can also be used by a web service, a web app. The layer 7 load balancer at this stage still can't be used by a web app yet. It can only be used by VMs. We will eventually make it work with the web apps. It's just one of those things that we are slowly getting around to making it work. Okay, one other thing I'm going to do, this you've got to bear with me for a while, is that I need to demo something called web scale VM skill sets. In other words, the ability to create VMs and so on later on. So the problem with that one, so in this case I'm digressing a bit, the reason why I had to do it earlier is because that thing takes a few minutes before it takes effect. So if you go in here and you look under the VM skill sets, okay, you will see some VM skill sets that I've built, but you will see some number of instances. So I'm digressing here because I have to kick off the VM skill set so that they'll start running more stuff first. And then once we do that, you will be able to see later on when it pops up. Oh, come on. The screen is too slow. I've clicked too fast. Okay, here we go. VM skill set. VM skill set here. And there you go. So you can see some of the VM skill sets that I've created. So in this case, the one I'm going to play around with is this guy. It only has 1 VM right now, all right? And that 1 VM uses the same load balancer technique to have something in front of it. That's why when you look under instances, you will see this guy. That's a VM. He's running. When you click on a VM, okay, you will then be able to connect to it, all right? Depending on where the, the ports are. So you have to go find exactly where the particular port is for him, and that is actually part of the load balancer. So this thing has a load balancer tied in front of it, and that has a particular port that is then open because of the load balancer. All right, so let me just pull out the load balancer here. And come on, load balancer. Here it is. So see the names? I kind of created them in a certain way so that you can kind of get to know exactly which one it is. But yeah, that's the load balancer for that particular thing. And you can see here that in that guy is a backend pool, which has only 1 instance right now, because that's the only VM that's running. All right? And that VM is then tied to a certain IP address and a certain port. So if I connect to this guy now, I'm going to kick off the CPU usage of it. So he will be 104.210.106.220:50,000. All right? Okay. So after I kick out the CPU, we'll get back to it in a few minutes' time, and then you'll see that it magically has got more instances running. Okay. So this is kind of a cheat because basically what I did was we used this software that we have, written by Mark Rasonovich some time ago, and all it does is that it fakes creating a lot of CPU usage. Okay, so I'm using this to bump the CPU usage really high. Okay, there you go. All right. So at that point, this machine is effectively going to be unresponsive. Okay. So now back to the load balancer stuff. Now you can see what a load balancer does and how it works. All right? All it is multiple things behind it. Each of them will then be assigned from the probe exactly what port you're looking for, and the load balancing rule will then specify this is the guy that I want to give it to, right? If you want to change all the weighting rules and all that, it's not really possible. Now, the bright side about this guy here is free. This load balancer is free. You don't pay money for it. Okay. There is another load balancer that we created, what we call the application load balancer. Okay. So that one is not free. Okay. So let me show you from here. So here's the other guy. This is the other load balancer that I'm going to show you. And, oh no, actually it's this one. Okay, that group. Okay, you'll see here, see this? That particular load balancer here, they call it a application gateway. That guy is not free. So what does this guy do? This guy, in many sense, is approximately like F5. It can understand HTTP. So for example, the previous one, I can't terminate my SSL or my TLS connections at the load balancer, because all it does is it just passes all the traffic through for whatever port you want. This guy, because it's layer 7, understands the traffic. So you can say, hey, I want you to take all the SSL, decrypt it on this part, and if you want end-to-end, I can re-encrypt it and send it to the backend. If not, I can send it to the backend as HTTP. Your choice. All right? So, and then other things it can do is it can also check, inspect the traffic, because layer 7, it can inspect the traffic. It can check whether you have a cookie injection attack, cross-site scripting attack, SQL injection attack, whatever, all those other stuff, it will be able to check for those and record that and give it to you. So that's where the article comes in useful. So this article basically talks about the three things that you have: the load balancer, the application gateway, and the traffic manager, and what they are different at. So one is DNS, one is layer 7, the other one is layer 4. And then notice that if you want to do within regions, you can use all three, but when you want to do across regions, only traffic manager will work, because the other two have to be in the same region that you're on. So that's why you can see here, HTTP, HTTP endpoint, HTTPS, and then the Azure load balancer is the only one that goes, you can take any protocol you want, because the probe allows you to do any protocol, and it allows you to, load balance any protocol, okay? And then again, same thing, what are the external stuff that can be done with it? So the idea here is traffic manager is what you do for external and what you do for region-based. That means you want the ability to be highly available across region, is traffic manager. Then you use either of the other two based on what you want, whether is it just a website, or maybe you might want to do some extra stuff like checking SSL, terminating SSL, checking for cross-site scripting, that kind of stuff. Then you use application gateway. If not, stick with the standard load balancer because it's free. Okay. Right. So with that, okay. So let's get back again and we talk about this stuff here. If you have a fast deploy for your web apps, you never need to back up. That's the key point here. As long as you can deploy faster than a restore, then you don't ever need to back up, because all you do is just deploy every time something goes wrong. DevOps, right? Okay. Although, of course, I'll say the other part, which is you don't want to do that at 3 a.m. on Friday night when everybody's screaming at you because it's Christmas Eve. Okay, right. Okay, now we talk about the IaaS stuff. So when it comes to the IaaS VMs, we have to put multiple of them. Notice that for the other stuff that I talk about, you actually only need one. You don't have to create 2 web apps to actually get HA, because the web apps are HA by themselves. But for VMs, you have to create 2 to get SLA. And the 2 you create, you must then create with something called an availability set. So the availability set is just something to tell us, to say, you know those 2 machines, I want them to be placed in different places. The idea here is that one fault will not take down the same thing. So when we call it a fault domain, it means, think of it as, it's actually a cluster of racks, but think of it as just like a set of racks, okay? If there's a power failure, maybe that set of racks will go down. If we put 2 machines in there at the same time, that means both of them will go down at the same time. So the idea behind having different fault domains is such that if, for example, we lose power, or we lose network connections or something within the data center, the maximum it will affect is 1 FD, 1 fault domain. And therefore, that VM within that fault domain, poof, you're gone. The next fault domain, on the other hand, stays up. All right? Then the other thing is we got something called an update domain. An update domain just means that periodically when we update the host behind your VM, we actually have to shut down your VM sometimes. And because we have to do that, what we do is we try to do it in a set of domains, in a set of update domains. That means we bring down everything in update domain 0, shut it all up, start it all up again. Once it's all started, we bring down update domain 1, shut it all down, do our stuff, bring up that one, and then we do 2, and then we do 3, and so on and so forth. So if you make sure that whenever you create VMs, you create 2 of them, and the 2 of them are always in different fault domains and different update domains, you can be very sure a single fault within the data center will not cause both of them to go down at the same time. And that's the reason why we say you have to do that. Okay? Now, what we don't tell you is that replication of the data is your responsibility. In other words, we just make sure one of the VM is up. Whether or not it's the right VM, that's your problem. Okay? Whether or not you updated that VM, that's your problem. Okay? We just make sure one of them is up. Okay? Starting in July or August, I think we sent out an update saying that from now onwards, for critical security updates, we don't actually need to shut down the VM. However, there will be a pause of up to 30 seconds within the VM. Okay? And the goal eventually is to not have to shut down a VM even if we have to shut down the host. That's an eventual goal. Whether or not we'll get there, that's a different story. Okay? All right, so let's look at a demo for this one here. Okay? So in this case, what I'm doing is same stuff here, but I've created the whole thing now. If you look at my virtual machines, so this set of virtual machines come under the same availability set. And because they come under the same availability set, hold on, let me go find my stuff in my VMs. Okay. So those 3 VMs that I showed you earlier, the 3 of them are tied together in one availability set, and 2 of them are Windows, 1 of them is Linux. See these 3 machines here? 450, 450, Ubuntu. Now, this is what I wanted to show you. If you look here, you will see that they have a certain public IP address. Because they share the same availability set, their public IP address is usually the same. If you go into the availability set, you will see here that this guy has got a certain number under his availability set, fault domains, and so on. Ooh, I clicked the wrong one. Yeah, it's this guy here, sorry. It's actually this guy, web VM1, and the availability set for it. There, you see the numbers showing up, 0, 0, 0, correct? Fault domain 0, update domain 0. Then you go to the next guy here. He has a fault domain of 1 and an update domain of 1. Okay, observe, right? And the last one here, which is the Ubuntu server, has got a fault domain of 2 and an update domain of 2. So because they all have different numbers, when a fault takes down fault 0, fault domain 0, it will not affect 1 and 2. Right? That's the whole idea behind how we get the availability of a VM. We do not care which VM it is. And that's the reason why, like I said, I put Ubuntu in together with 2 Windows machines, and we don't really care because it works the same way to us. Okay. So if you go into the availability set, that's where you can actually see the whole information now. The availability set will tell you that it has got 3 fault domains, which is the max you can get. It has got 5 update domains, which I haven't used the other 2. And there are 3 virtual machines in there. And if you look at the virtual machines now, it shows up quite clearly. There you go. Those are the virtual machines that you saw. All right, 0, 0, 1, 1, 2, 2. So all of them, by design, will automatically be highly available simply because of this. All right. Now, back to the slides again. So that covers for you what a real HA will look like on a VM level. You have to ensure that you are doing your own replication, and because we put it through an availability set, when one of them goes down, the probe knows which one goes down. It will automatically send traffic only to the one that's up. All right. Now, if you're running a SQL VM, this is where it gets a bit more complicated. All right. With SQL, what we have to do is you basically have to set up always on within the SQL server, and because now it's yours, it's not SQL Azure, this is your own VM, we usually do synchronous replication within the same data center, asynchronous replication across data center. Now, please note, there is nothing prohibiting you from saying, I want synchronous replication across data center. Right? For example, if I got something that only changes 5 times a day, and I don't mind waiting for it, then fine, just let it go and I'll just get the thing. It takes slower every time you do a write, but other than that, it works fine, okay? So that gives the always-on capability across data center. With 2016, we created something called storage replicas and storage spaces direct. Go through those articles if you see it. Storage spaces direct, for example, is really, really cool, and it's something that you can do. Now, the other problem comes with SQL, which is that your cluster heartbeat, because of the VMs, the fact that they can be paused up to 30 seconds, when that happens, your cluster will fail over because it assumes that something has died. Because by default, the cluster heartbeat is 5 seconds. So now, the question is, do you want to change it or not? That depends. The answer from our side has been that, well, since it's 30 seconds, you can, if you want to, go up to 40 or something, and that kind of like mitigates that whole thing. The last thing is you got to make sure an app that you're using is reconnecting on any failure. Okay, so let me show you my SQL Azure cluster. I mean, not SQL Azure, sorry. This is my real SQL cluster. So here it is. So this was built from Azure using the standard template that they provide. And here it is. This is, let me see, which guy was it? The fun thing about having too many VMs running at the same time. It's probably this guy, right? Let's see if I'm right. Okay, yes. So this is the cluster itself, because if you click fail over cluster, you can actually see it. First rule of thumb, don't change anything here. If you do, the DBAs will kill you. All right? Do not touch anything from here. So this actually is what we call the listener, and that's the SQL server that's listening on it. You touch this, I guarantee you a DBA will come after you. Okay, so do not touch that. But the one thing you want to change is the cluster heartbeat, and that can be changed from here. So if I run PowerShell, and I run PowerShell in an admin mode, oh, it's a bit small, okay, and I'll change that font to something larger so you can see it. So if I do a get dash cluster, it will return back the cluster itself, right? What you're looking for is all of the properties of the cluster. The property I'm interested in showing you is something called same subnet delay, same subnet threshold. See these numbers? It means that every 1,000 milliseconds, we will send a ping between all the people. After 20 pings have been missed, we declare the cluster down, and then we'll start to reassemble. There's a corresponding one for cross. So if you kind of do a shift up, you will see that there's a corresponding one for cross subnet threshold and cross subnet delay, right? So you want to change those values to something larger than 20 if you are worried about a 30-second time, okay? Now, let me go into my AD. So within here, there is an Active Directory server, which I need to find, and I think it's probably this guy here. If I got it right, he should be the domain controller. I think he's right, yeah. So imagine now I'm the domain controller, I'm connecting to it, okay? In this case, think of it as just a SQL Server client. I'm going to show you the effect of me shoving things around and deleting things and moving things back and forth, okay? Because this is synchronous, right? You connect via the name of the listener, which I think was contoso-ag, if I got it correctly. Or did I get it wrong? I think I got it wrong. Okay, what was the name of it again? I was pretty sure it was contoso-ag, but yeah, it is. Oh no, that's not the name of the listener. The name, yeah. Contoso listener, sorry, that's the name of it. Contoso listener. Okay, back up here again. So if I connect as Contoso listener, all right, you get to the database. And the currently replicating database is this guy here. What you connect to will always be the primary. So let me show you what I mean. If I do here, I connect to it, and I do a select add version, and I run it, it's going to run fine. See that? Now, we know that the current primary is one of the two. Can't tell which one, but it's one of the two, right? So if I go in here and I find that, hey, the current owner is 0, right? If I go into 0 and I just do something like, say, SQL Server number 0, I will then try and shut it down, which is this machine, by the way. I think this machine is SQL Server number 0. I then just do that. Guess what happens to your SQL Server? Boom, it's gone. All right? Bye-bye SQL Server. Now, at the same time, if I go back to this guy and I run the command again, notice it's still functional. Sometimes you will get a small time where it goes connection failure, TCP connection failure, you can't see the thing. You retry again and you connect. Why that works is because SQL Server, by design, will automatically detect all of this stuff. The cluster will automatically send the listener to the right spot. And because your data is synchronized, there is no data loss. Okay? But your apps have to reconnect when needed. If they don't, it will fail. Okay? Now, some apps, example SAP, won't reconnect. What you have to do is you got to go to the application server and restart them. Every time you shove things around, you have to restart them because they can't reconnect to the new one. It will only reconnect on startup. Okay? So hopefully you don't have too many of those apps, then you will know eventually which are the ones you have to restart because you know from the fact that they are the ones that always cause trouble every time something changes. Okay. So next, what about VM skill sets? So VM skill sets is basically the ability to create a VM from a single base VHD, and then as and when things are going up or down, we increase for you. We create new instances as needed, and then we put them down when we realize that you don't need them anymore. So part of the rules you place in the VM skill set says, for this VM skill set, I need what number to go up every time your CPU gets to a certain range. Every time it goes down below a range, I will then drop it off. So let's give an example here now for my skill set. And you can actually see it because that's why I was running the thing earlier. So if we go back to VM skill set now, you should be able to see that in my skill set, instead of one instance, which is what I showed you just now, it should now have a lot more than one. Okay, come on, where's my VM skill set? There you go. Oh, sorry, forgot to change the screen. Okay, get back here again, and there it goes. All right, VM skill set. See that? The skill set is updating. Why? Because it is no longer one instance. See that? It's bumped up the tree. Because it realized that in the last few minutes, the CPU usage has gone through the roof. It's gone on and say, yeah, now I need 3 instances. All right? How it will go up is dependent on the, what do you call that, the numbers you set. So I'll just give you an idea. Basically, what I did was I just took this as a JSON file. All right? And I'll show you what it looks like here. This was just taken from our standard samples. So nothing special, and I'll just open it with Notepad because it's easier to see. Okay, here you go. All right, hope everybody can see it. Okay, so first I pick where it came from, and in the case I just picked 2012 R2. Now look at the very bottom of it. It has all these numbers here under the auto scale part. What I've just said is this profile. First off, it means that I will have a minimum of 1, a maximum of 10 as the number of VMs that I'll create. This here says that I will look at processor time, and if my processor time, I'm looking at it every minute, I average it over 5 minutes. If the average is greater than 50% over the 5 minutes, then the action I will take is increase the count by 1. And once I increase, I'll wait 5 minutes before I do anything else. That's what a cooldown means. Okay, then you go the other way around. Same counter, but this time around, I'm checking the average again over 5 minutes. If it's less than 30, if it's less than 30, I will start cutting it down. Okay, cool. So basically, that's how we ensure that we can get something ramping up, and then when something goes not used anymore, we ramp it all down. See, this is way different from a website, because a web app, I can do the same thing straight from the portal. Because in the portal, I can just say, I want how many instances, and you create that for me. Here, I have to create it all myself. And then what they will do is, within the VM skill set, they will use the load balancer to ensure that the traffic goes between them correctly. All right? So that's where a load balancer is really, really, really great. Okay? And the skill set will really help you if you need multiple of them. Now, here's the bad news. Because when we shut it down, we just shut it down by itself, we can't guarantee that we'll run any script. We actually don't run any script on shutdown. If you are trying to do a domain join machine, it gets a bigger headache. Because a domain join machine, when it comes out, you can run the script to add it, but sometimes you can't run the script to remove it from domain. Okay, so this tends to be used not really for domain stuff. So any questions on all the things I've done so far? Nope, this is the last part here, storage accounts. So storage accounts are highly available within themselves because you got 3 copies of each data. They're geo-redundant if you want. Please note, we have never published an RTO for geo-redundancy. Okay, so if you need a specific RTO, you must use something like SQL Server Always On because it guarantees the data is over there, and then you can kick it off at any time. Well, in the first place, we haven't really got a massive data center outage yet, okay, that we can actually declare that we need to use a geo-redundant capability. So because of that, I tend to tell people, don't bother with geo-redundant, only use it for things like backups, just so that your backups appear on the other side, right? And also use it for things like stuff that you know doesn't change too much and you know will appear on the other side, okay? So if you are going to use RAID storage spaces and so on, then we'll suggest that you use locally redundant storage. The reason why you can't use geo-redundant is because we cannot guarantee the order of the writes. So if I have a VM that has got 5 VHDs underneath it, and then I RAID them together, I cannot guarantee that those 5 will appear on the other side the same way. Meaning to say, I cannot guarantee that those 5, when I get to the other side, I can form the RAID array anymore. So don't do that. So every time you use things like RAID storage spaces direct, you must use locally redundant. Okay, this is the last slide already. So how about hybrid? So hybrid is pretty easy, right? If I want hybrid connection, I create 2 instances. Okay, they're automatically HA. Azure AD application proxy, I create 2 instances. Okay, they are automatically HA because either one of them will take on the route. Well, VPN gateways, we don't actually say it's HA, but we give you an SLA guarantee of 99.9 or 99.95. We don't meet that, we pay. Okay, but it's not guaranteed to be HA because of that. The express route gateways, on the other hand, are guaranteed to be HA because for express route gateways, we always use a pair, a redundant pair. So it's actually, on the router, we actually have 2 separate ports that we're using on it. 2 different routers, 1 port each. Unfortunately, the last line still counts. If you misconfigure your network, that's your problem. We don't pay up. Okay, all right. Okay, and with that, that comes with all the slides that I have. I hope this was a good explanation of how you actually get HA in Azure. All right, questions, anyone? Okay. Sure.
If I'm using a scale set, will it automatically distribute them across multiple?
It always uses the equal part. So that means, remember, it uses a load balancer. It just adds it into the backend pool. So the backend pool of the load balancer, once you add something, they will automatically probe it and do stuff against it.
But are those instances distributed across different fault domains?
Oh, yes. Okay, but we try. Not guaranteed, though. Okay. Yeah, because you only have 3 fault domains, right? Yeah. No other questions? Cool.